Saxon's Trig, lesson 97, is about the ambiguous case. And ambiguous here means capable of two or more interpretations. So what's happening is I'm being given information like an angle is 40 degrees, its opposite side is 4, and another side is 9, without being provided a diagram of any kind. I have no idea whether I'm dealing with a right triangle, an acute triangle, or an obtuse triangle. So to help us try to sort that out, I drew a right triangle, and I'll go over this information in a second. But in order to find the height to test it, I will do the sine of 40 equals the height that I'm trying to find, because it's so opposite over hypotenuse. And whatever the other side is, that is the one that we are going to assume is the hypotenuse. So it works well when I'm drawing the right triangle. It doesn't work so well if I draw any other kind of triangle, but just to test, you're going to then do sine of 40 on the calculator times 9 and discover that the height is 5.79. So now I compare what it actually comes out to be, 5.79, with what they gave me that it was, a 4. Now this is where this comes into play. So if finding the hypotenuse, or the height, doubling is the hypotenuse in this case. If they're equal, then it's a right triangle. If, however, the 4 is less than the 5.79, I will not have a triangle. So with this given information, the answer is no triangle. If the given side length is longer than whatever I discovered the height to be, I will have either an acute or an obtuse triangle. So now that was example 1. So this information I would definitely put in my notes. Let's look at example 2. I am given A is 27 degrees, little a is 5, and B is 7. So since I don't know what kind of triangle I'm drawing, I'm going to start with doing sine of 27 equals the height, assuming it might be a hypotenuse, over the other number, the 7. Sine of 27 times 7 tells me that the h is 3.18. So when I compare 3.18 with what they gave me, which is a 5, that's larger than what I found, 3.18. So I either have an acute triangle or an obtuse triangle. And I don't even want to attempt to draw it, because I have no idea which one I have until I use law of sines. So we're going to do our 5 over sine of 27 equals the 7 over sine of, and since that was a little b, this is going to be a capital B. And then sine of 27 times 7, divide by 5, second, shift, or inverse, however your calculator does it, to spit out the degree. And you should get that B is 39.46 degrees. Now, so far I know I have a 27 and potentially a 39.46, but I also need to find what B's other version is, which we do by 180 minus the 39.46. And so that gives us 140.54 degrees. So these are the two possible B degree answers. So if I take 27 plus the 39.46, I get that the C, I want to make sure I use the right one. If B, no, not that one. If B is the 39.46, then C ends up being 113.54 degrees. And here, if I add 140 plus the 27 and take it away from 180, we get 12.46 degrees. So now what I notice is that this is 113 more than 90, obtuse triangle. This is 140 more than 90, so I have two potential obtuse triangles that could be created here with this information. So I want to make sure I label the obtuse one correctly. I know A is going to be a 27 degree, so this one could also be the 27 degree. Here, if I label this, now I'll do them first. Okay, so C is the 113.54 degrees, and then the B was the 39.46 degrees. And then over here, the obtuse is the B, so that one's the 140.54 degrees. Then this one is the C at 12.46 degrees. So I have two obtuse triangles. We've labeled the degrees. Now I should finish labeling in the parts. So I know that opposite the A is the 5. I know that opposite the B is the 7. Opposite the B is 7. Opposite the A is the 5. So the last piece of information that I need is what the C would be in both of these. So you can go ahead and do C over sine of, and then for this one, that would be 113.54 degrees. So whoops, you're going to do sine of 113.54 times 5 divided by the sine of 27. And make sure I pull from the right one. I did the 113 one. So that one is 10.1 or 10.10. And then when I do the same thing, except I use the 12.46, and then of course the same cross multiply, this C ends up being 2.38. And now I have found all of the parts, but it required me to have two different obtuse ones. And I could have had two different acute ones, but hopefully you get the idea of what they're looking for here. When all they give you is the list of information without a picture, use this set of information to help you figure out what kind of triangle you're dealing with.